Today we're going to work on section 11.5, the distance and midpoint formulas. What you see on your screen right now is the distance formula. You need to be given two xy pairs. One of them is going to be x1, y1. The other one is x2, y2. And you will find the distance between these 2 points on a coordinate plane. In order to use the formula, you will be subtracting your x's, x2 minus x1, and squaring that difference. Then you will be subtracting your y's and squaring that difference. And finally, you will be adding those two squares together. Once you have that sum, then you can go ahead and take the square root of that sum. And that will be the distance between the 2 points. Be careful to follow your order of operations on this formula. Let's go through and use this formula. I have 2 points up here. Let's let this one be x1, y1, and we'll let this one be x2, y2. It truly does not matter which one is which as long as you have both of them with the same subscripts. So our distance is going to be equal to the square root of, let's do our x2 minus our x1. So that's going to be 2 minus a negative 3, which is really 2 plus 3, quantity squared, plus y2 minus y1. So we will have 3 minus 1, quantity squared. In the end, we'll add those together and take the square root. 2 plus 3 is 5, so that's 5 squared. 3 minus 1 is 2. That is 2 squared. We'll keep the square root over that. In our next step here, we have 25 plus 4. And 25 plus 4 is 29, and we'll have the square root of that. For the purpose of our answers, we wanted it to be in a radical form. Square root of 29 is our distance, so distance equals square root of 29, and we will put units behind that as a label. If they ask you to round that answer off to the nearest hundredth or tenths, then you would pick up your calculator and find out what the square root of 29 is. For our problem, we left it in radical form. The distance between 4a and 1/6 is 5 units, and it says find the value of a. So here we're actually needing to find the value of one of the coordinates, one of the x or y pair. So we are going to start with our distance is 5 units, equal to the square root, and let's let this one be x1, y1, and this one be x2, y2. So I'm doing 1 minus 4, 1 minus 4, quantity squared, plus our y's minus each other, so 6 minus a, quantity squared, and then the square root of all of that. Now 1 minus 4 is a negative 3, and that gets to be squared, plus underneath the radical there is 6 minus a, quantity squared. And so we have to use our rules from chapter 9 with multiplying binomials. This will give us 36 minus, we're taking these two times each other times 2, minus 12a, and then the last term squared plus a squared. That is all underneath the radical equal to 5. Combine any like terms that you can. Here we have a positive 36, and we know that this number is 9, so 36 plus 9 gives us 45. So let's rewrite things a little bit underneath here. Let's have a squared minus 12a plus 45, all underneath the square root, equal to 5. Well, when we've had square roots in the past that we've had to get rid of, we need to make sure to square both sides of the equation, and that's what we're going to do here. So we will have 25 equals, now it's a squared minus 12a plus 45. Let's get this into standard form so that we can solve the quadratic equation. Moving the 25 over gives us a squared minus 12a plus 20. And now, if you can factor it, great. If you can use the quadratic formula, great. You want to complete the square, great. You want to graph it, well, feel free. But at this point, I would probably take a look at seeing if I could factor this one. And we have all the factors of 20, which are 1 and 20, 2 and 10, 4 and 5. And if I make both of them negative, I will have a negative times negative be that positive 20, and negative 2 and negative 10 do give me negative 12. So a minus 2 and a minus 10 would be my two factors, my binomial factors. Set them each equal to 0, and then we can solve for our a. A will be equal to 2, and a will be equal to 10. We actually have two answers for this problem. We have a equal to 2 and a equal to 10. That means there are going to be two different coordinates that would have a distance of 5 between that coordinate and 1, 6. You could go 4, 2 and 1, 6, or 4, 10 and 1, 6. And between them, they would have a distance of 5 units. So there are two answers here, and we found that through solving our quadratic equation. The other formula that we have is the midpoint formula. Now, the midpoint is that place that's directly in the center between two other points. And so we want to find that middle place. A and B being our endpoints, M being our midpoint. How do we find that? The formula is the following. We have M is equal to, again, we have two coordinates. This one, let's say, is x1, y1, and this one is x2, y2. We are going to add our x's together and divide that sum by 2. And our y's, we are going to add together and divide that sum by 2. The numbers we end up with is a coordinate pair, and that will be our midpoint coordinate pair. So we want to know the midpoint of this line segment that has these two endpoints. Okay, our midpoint will be equal to, we're going to add our x's together, so we have negative 3 plus 7, all divided by 2, and we're going to add our y's together, negative 1 and a plus a negative 5, all divided by 2. Negative 3 plus 7 is 4, 4 divided by 2. And negative 1 minus 5 is a negative 6, all divided by 2. Simplify your fractions, and you get the midpoint being 2 comma negative 3. That midpoint is our answer. We put a box around it. Very simple equation, very simple formula actually, where you just add your x's together, divide by 2, add your y's together, divide by 2, and that completes your XY pair for your midpoint. Good luck on the distance and midpoint formula. Have fun!